Hello Year 12 Chemistry, this is Mr Nicholson, and this is a video that has been recorded on the 18th of November, and today we'll be discussing how we're going to model dehydration and hydration reactions. And we're doing this to satisfy the syllabus point, process information from secondary sources such as molecular model kits, digital technologies, or computer simulations to model the addition of water to ethylene, or if we're going to be systematic about it, ethene, and the dehydration of ethanol. Now, I'm making this video to talk about the scope to which you have to work to when you're actually doing your models. And the reason for that is because it's not always clear how far you have to actually go when you're looking at dot points. This is a really good example because on its face value, this dot point points you at the chemical reaction mechanisms. So that is the actual mechanics of how these reactions are happening, and that is actually above the scope of the HSC. And it's only once you actually get a little bit used to reading the dot points you can actually clue in on the point that the questions that you could be asked from this dot point is actually how you modeled this process rather than the details of the process itself. So with that being said, I have linked in the lesson materials additional websites and additional explanations of how the mechanism for these two reactions actually works, but you do not need to go to that level of detail. And in this video I'm going to show you the level of detail you need to go to. So, as we get started, first thing we need to do is look at the players in our model. We have ethanol, as you can see just here. And you've built this before, it's a familiar molecule. Alright, we have ethene, another familiar molecule. You can see the double bond just there. We built that one before as well. And you have water, we certainly know that one. Alright, but one you're familiar with, but you're not familiar with the structure of, is sulfuric acid, which is shown just here. And that, if you actually have a look at this, it makes a lot of sense of structure. You've got H2SO4. And with this molecule, it's a bit of a beast of a thing. The hydrogens, they're really the business end of this molecule. And so these are our four players in these two reactions. We have ethanol, ethene, water, and sulfuric acid. So, let's just take a look at chemical reactions in general. Now, when we're talking about chemical reactions in general, we need to point out that what's actually happening is you have a chemical reaction, right? You start with reactants, they collide together, a reaction happens, and they form products. And we're interested in this reaction part, and that is where we have successful collision. They need to collide together, our reactants need to collide together in the right way for the reaction to proceed. They need to meet the small hump of energy required for the reaction to proceed, and that's where the catalyst can interact. They can lower that amount of energy. And finally, they need to rearrange to form the products. And that can be quite a challenge at times as a chemist to actually get chemicals to behave. And so what we're going to do today is we're going to examine this process. And we're going to start by doing this for the dehydration of ethanol. That's where you have ethanol in the presence of concentrated sulfuric acid, and what happens is a water molecule comes out of that and we form ethene. So let's have a look at that. Alright, and we'll just use this little structure just here as a little guide. And so we start with our ethanol just here, and what's actually going to happen is when we actually add some concentrated sulfuric acid, they're going to collide together and it's going to cause the ethanol to rearrange. Now when you model this, you should be manipulating this model. For the purpose of time, I'm just going to swap it out. Alright, so we'll have some movie magic, and what's going to happen is it's going to have rearranged into ethene and water, and our catalyst is going to come out unchanged, and we have our two products formed. And that's our reaction, that's what you're modeling. And that's the type of process that you have to be explaining. Now, same idea when we look at the hydration of ethene. Okay, and so for the clue students, you will notice that one uses the same catalyst, which is interesting. Alright, but if you actually have a look at some of the further information I've given you, you actually will look at mechanically, this reaction is the exact opposite. We start with ethene and water, and when we actually have these and we bring sulfuric acid into contact, they form ethanol, which is the reverse of the other reaction. So let's have a look at modelling this process. Alright, so we bring our reactants into play. They need to collide, and along comes our catalyst. That causes them to rearrange. We'll have some more movie magic, and that causes them to rearrange as ethanol. And our catalyst interacting with that comes away unchanged, and our ethanol forms our product. And really, that's all there is to modelling this process. Alright, remember, when you do it, you should be rearranging the models yourself. You should actually be pulling this apart and adding the water in this case, and in the other case taking the water molecule out for the dehydration reaction. Alright, but in a nutshell, that's actually how it happens. Now, when you do this, you should be making some sort of record of it. Now, I would recommend making a video with your phone, which is exactly what I'm doing right now, and I've just got it set up on a retort stand, or taking a series of images. Now, in this exercise, what you're doing, we are modelling. We are modelling a pair of reactions. And so when we model something, we need to be able to talk about how we did it. And what that means is talking about it in terms of advantages and disadvantages. So, the language you need to be mindful to use is in terms of advantages, is how you've simplified a complex process and how you've made it clear. Now, in terms of disadvantages, you really need to clue in and talk about misconceptions. Now, if you have a look at further detail at these mechanisms, you'll notice that our models don't actually show what's happening to the electrons. That's a layer of detail we haven't included. And so there's actually the genuine criticism that we have oversimplified these reactions by not showing those electrons. Alright, and so it really just shows you there's always more detail when we can look at these reactions. Alright, chemistry students, stay frosty. This is Mr Nicholson, and I'll see you in class. Bye!